Okay, so from next class, if I forget to record the class, please let me know. Yeah, because I'll be recording all the classes and I will post the recorded video on YouTube and I'll send you the YouTube link so that if you miss any information, you can watch it later. Okay. Yeah, I'm sorry, I forgot to record the class today. Okay, I started recording now. Okay, so we'll go over the basic statistics. So from the first chapter, we'll go over only section 1.1 and section 1.2. So section 1.1 is statistics basics. So we'll just go over some definitions and related examples. So the first definition is descriptive statistics. So what is descriptive statistics? So this consists of methods for organizing and summarizing information. So what is actually statistics? Statistics we collect in statistics, we collect data, then we gather information and we organize the data and we gather information from the data and we summarize the information, then we interpret the information. So that's the statistics. So what is descriptive statistics? So this is methods for organizing and summarizing information. And descriptive statistics include the construction of graphs. So we can organize and summarize the information of the data in different ways. We can use graphs, charts, tables, and we can also calculate some measures. We can calculate the averages, measures of variation, and percentile. So these are called descriptive statistics. For example, if we calculate the average score of this class, so this is also a descriptive statistics. So here is an example. Oh, I'm sorry. So the 1948 baseball season, in 1948, the Washington Senators played 153 games and winning 56 and losing 97. So they finished seventh in the American League and were led in hitting by Bud Stewart, whose batting average was 0.27. So here we have average, we have total number of games and number of wins and losses. So this is actually descriptive statistics. Okay, so here is the definition of population and sample. So these two term is really important in statistics. The first term is population and the second one is sample. So what is population? Population is the collection of all individuals or items under consideration in a statistical study. So if you want to do a statistical study and the collection of all individuals or items under the consideration in that study is called the population. So that's mean if we want to know the class average or if we want to know the average score in the first exam of our class. So who are the individuals we are interested about? We are interested about the students who are taking this course, right? So that's when all the students who are taking math 2300 course is our population, because we are interested about the average score of the students who are taking math 2300 course. Now, what is sample? Sample is the part of population from which information is obtained. Okay, so we want to know the average score in the first exam for the math 2300 students. But we are not going to, so since this class is not big class and the number of students are not very large, so we can collect information from each individual. But think about another example. If we want to know the average height of all US adults, so it is actually very expensive and time consuming and very unrealistic, like to measure the height of all US adults and then calculate the average of the height of all US adults. In that case, what we can do, we can just randomly select some US adults. So we can randomly select maybe 1,000 US adults, or we can randomly select maybe 500 US adults, and we can just measure their height and calculate their average height. And based on this average height, we can make inference about the population. We can make inference about the average height of the all US adults, right? So what we did here, we selected only 500 US adults or only 1,000 US adults among all US adults. So this 500 or this 1,000 US adults is called the sample. So that's mean this is a subset of the population. So basically the sample is a subset of a population. So that's mean this is the sub collection of individuals from the population. Okay, so here is an example. Political polling provides an example of inferential statistics, interviewing everyone of voting age in the United States on their voting preferences. So if we want to know the voting preferences of the United States voting, so it will be very expensive and unrealistic to interview everyone of voting age. So what statisticians do in that case? Actually, they just randomly select a group of people, or they select a group of people from the population from all US voting ages people, and then they ask them question to the group of people, to that group of people, the selected group of people. So here, this selected group is called sample. And what is inferential statistics? Inferential statistics is, so what we did in that case, the statisticians did in that case, they randomly select a group of people and they interviewed that group of people about the voting preferences. And based on their answer, they made inference about the all voting ages people. So this is called inferential statistics. And consider the previous example where we were talking about the average height of all US adults. So what we did, we just randomly selected 100 US adults, and then we measured our 500 US adults or maybe 1,000 US adults. Then we measured the heights of that selected people and calculate the average. And based on their average height, we made inference about the average height of all US adults, right? So this is called inferential statistics. Okay, um, so I have a question here. So will you post this in the Blackboard? Yeah, I'm going to actually, I'm going to post the recorded lecture on YouTube, and I will send you the link. The link will be posted on Blackboard, okay? So relationship between population and sample. So you can easily see the relationship between population and sample here. So this is our population. Population is actually collection of all individuals. So here we have all the individuals here in our population. And in our sample, among all the individuals, we just only selected 4 individuals here, right? You can see here 4 dots, 1, 2, 3, 4. So this is actually part of the population, right? So that's mean the sample is a part of the population. So we can also randomly select another 4 or 5 individuals from here. And this is another sample. And we can also select another 4 or 5 individuals here. And this is another sample. So from the population, we can draw many samples, or we can take many samples from the population. So sample is a subset of the population. This is a part of the population. Okay, so I have another question along with the recorded lecture. Would you be able to post the PowerPoint? Yes, I'm going to post the PowerPoint on Blackboard as well. Okay, thank you for your question. So here is an example. 4 out of 5 dentists recommend Crest toothpaste. So from this information, we can predict that 80% of all dentists recommend Crest. So we only asked 5 dentists and we found that 4 out of 5 dentists recommend Crest toothpaste. So here the sample is 5 dentists, right? So we asked only the 5 dentists and we found that 4 out of 5 they recommend Crest toothpaste. So based on this information, we are making inference about all the dentist recommendation, right? So we are saying that 80% of all the dentists recommend Crest, but we didn't ask all the dentists. We asked only 5 dentists and we found that 4 out of 5 recommend Crest toothpaste. So that's mean we are making inference about all dentist recommendation based on our sample, right? So here is another example. Sally's 4 bowling scores were 115, 142, 129, 134. So the average bowling score is 130. So only based on 4 bowling score, we calculated the average and we found this is 130. And we are making inference about Sally's all bowling score, right? So do you have any question? Is it clear what is sample, what is population, and what is the difference between sample and population, and what is the relationship between sample and population? Actually, this is really important to know because in the later chapter, actually, we'll use this concept mainly when you will be doing you will be studying the confidence interval, the hypothesis test. You need to have the clear idea of population and sample. Is it clear what is population, what is sample? Okay, that's good. Thank you. So here are some average salaries of various occupation in 1999. Okay, so this is also an example of descriptive statistics. Oh, I'm sorry. So there is another example. In order to predict the upcoming presidential election, a political polling company surveys 20 Americans about their political affiliation. Okay, so they only asked 20 Americans. So here the 20 Americans is the sample. And all the Americans is our population, right? Is the population in this case. So classifying statistical studies. So we can classify statistical studies in 2 different statistical studies. First one is observational study, and the second one is designed experiment. So what is observational study? So in observational study, actually this is two different way of gathering data or gathering information. So one is observational study, the other one is designed experiment. So in case of observational study, researchers simply observe characteristics and take measurements. They do not do any experiment. They just observe the characteristics and they take measurements. They collect the information. And in a designed experiment, researchers impose treatments and controls and then observe characteristics and take measurements. That's mean in this case, they do experiment. Okay, so let me explain more about this. Okay, so an observational study observes individuals and measures variables of interest, but doesn't attempt to influence the responses. They just observe the individuals and collect the data. Nothing is influenced by the researchers. So researcher actually doesn't influence the response. They just look, but they do not touch. So that's mean they just observe. They do not do anything. They do not influence the response. But an experiment that deliberately imposes some treatment on individuals to measure their responses. In an experiment, the researcher has control of the variables of interest. So that's mean the on the responses, the researcher has control in case of experimental studies. So if you look at this two picture, the first one, you can see here, this guy is basically just observing and collecting data, right? This guy is just observing. And if you look at this picture, the second picture here, you can see that they are not just simply observing. What they are doing, they are doing some experiment. So they are doing some, maybe some chemical experiment, and she's doing some major science. And this guy is helping. Yeah. Actually, this is like very good representation of the observational study and the experimental design, because it is very clear that this guy is just watching, but they are doing some experiment. Okay, so now we'll go over some example, and we'll determine whether it is observational study or experimental study. So in the first example, does reducing screen brightness increase battery life in a laptop computers? So this is the research question. So we want to know whether reducing screen brightness increase the battery life in laptop computers. Now to find out, researchers obtained 30 new laptops of the same brand. They chose 15 of the computers at random and adjusted their screens to the brightest setting. The other 15 laptop screens were left at the default setting. Researchers then measured how long each machine's battery lasted. Was this an observational study or an experiment? What do you think? Is it observational or experiment? Yes, this is a designed experiment, right? This is an experimental study. Okay, thank you. So go over another example. Does eating dinner with their families improves students' academic performance? So this is the research question. So now, according to an ABC News article, teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. This finding was based on a sample survey conducted by researchers at Columbia University. Was this an observational study or experiment? What do you think? It is observational or experiment? Yes, it is observational because they didn't do any experiment. So they didn't influence the students. They do not have, the researchers do not have any influence on the academic performance of the students, right? They just observed the academic performance of the teenagers, right? Yeah. So this is an observational study. So in your first homework, actually, most of the questions are related to experimental study and observational study. So that's why you need to have like very clear idea about observational study and experimental study or experimental design. Okay. I think now it is, do you have any question? So if you do not have any question, we'll go back to our previous slides. Okay, thank you. Yes, okay. Okay, so this is all about first section. The second section is simple random sampling. So we discussed about sample and population, but how do we collect sample? Okay, so how do we collect sample? The methods of collecting sample is called sampling. So there are different methods or different way of collecting sample. One method or one way is simple random sampling. Okay, so simple random sampling or simple random sample. So simple random sampling is a sampling procedure for which is possible sample of a given size is equally likely to be the one obtained. So what does it mean actually? That's mean from the population we can collect different samples, right? So okay, I'm trying to, oh, yes, it's working now. I'm sorry. So suppose this is our population and we have these observations in our population or these individuals in our population. Now we collected a sample of size 3. We collected 3 individuals from the populations. So this is our first sample. So maybe we collected these 3. So we have also other individuals in our populations, right? So we can also collect these 3, right? We can also collect these 3. So we can also collect these 3. Or maybe we can also collect these 3. So that's mean we can collect so many samples from the population, right? With same size. So if all the samples have equal chance to be obtained, then this is called simple random sampling. So for example, we want to know about the average score of Math 2300 class, but we are not going to collect the information from each student. We'll just only randomly select 10 students from the class. We'll select 10 students from the class and we'll ask them about their grade in the first exam, and then we'll calculate the average grade for those 10 students. So how can I collect the samples? So we can just randomly select 10 students from the class, right? So, and in that case, each student has equal chance to be selected, right? If we randomly select 10 students. So each student has equal chance. So when each sample has equal chance to be collected, then it is called simple random sampling, or simply SRS. SRS means simple random sampling or simple random sample. So what is simple random sample? The method is called simple random sampling, and the collected sample is called the simple random sample. So simple random sampling can be done in 2 ways. One is with replacement and the other one is without replacement. So what does it mean by with replacement? So for example, we collected this sample and then we replaced the sample in the population again. So that's mean it has chance that it will be collected again. So this is called sampling with replacement. But if we collect the sample and if we do not include them in the population again before collecting another sample, this is called sampling with replacement, without replacement. Or for example, if we want to collect a sample size of 10 to calculate the average score for Math 2300 class, we can randomly select 1 student and then we can ask the student scores. So if we do not consider him again to collect the sample, this is called without replacement. So that's mean we are not including the first person, or we are not including that person in the population again, before collecting the next individual, before selecting the next individual. This is called without replacement. Okay, so here is an example. A substitute teacher wants to know how students in the class did on their last test. The teacher asks the 10 students sitting in the front row to state their latest test score. He concludes from their report that the class did extremely well. What is the sample? What is the population here? Can we identify any problems with choosing the sample in the way that the teacher did? So here we have actually several questions. A substitute teacher wants to know how students in the class did on their last test, and the teacher randomly selected 10 students sitting in the front row. So remember this, sitting in the front row. He concludes from their report that the class did extremely well. So what is the sample here and what is the population here? And do I identify any problems with choosing the sample in the way that the teacher did? So what should be the answer for the first question? So what is the sample in this case? So what is our sample in this case? Yeah, 10 students sitting in the front row, right? Yeah, the 10 students who are selected. Yeah, you're right. So this is the sample here. So what is the population here? Yes, the class. That's mean all the students in that class. Yes, the population is the class. Yeah, you're right. Thank you. So do you see any problems in choosing the sample the way teacher did? So what type of problem might happen in that case? You can also unmute and use your microphone. Yeah, if you do not want to type. Yeah. Yeah, students are not randomly selected. And do better cause, yes. So I found many answers. The problem is he only chose the front row, no one else. Yes, the people in the front row probably do better because they can pay more attention. Yeah, yeah, true. Students in the front row are not randomly selected. True. Front row students pay better attention normally. True. Yeah. So that's mean actually these 10 students doesn't represent the whole class, right? Because they are not randomly selected. So actually this is called a biased sample. So in this case, we didn't do simple. So is it a simple random sampling or any other sampling? Is it simple random sampling? What do you think? No, this is not SRS, right? Yeah. Yeah, this is correct. It might not be a representative sample. Sample always must be representative sample. Otherwise, the study you will be doing or the statistical study you will be doing is completely garbage. It doesn't make, and it will not make any sense. Yeah. So this is not simple random sampling because all the students doesn't have equal chance, right? Because the teacher selected 10 students from the front row. So that's mean the students who are sitting behind, they do not have any chance to be collected or to be selected. So this is not a simple random sampling. Okay, so now the question is, how do we collect a simple random sample? So we can use random number tables, but nowadays actually no one uses random number tables because this is very time consuming and this is not very useful way to collect simple random sampling. Now people use actually computer to collect simple random sampling. Computer can automatically generate simple random sampling. Yeah. So, but we'll go over the random number tables. It's better to just know how we can use random number tables to collect simple random samplings. So this table is called random numbers table. So the first column is the line number and the first row is the column number. And these numbers are random numbers. So we want to choose 15 students out of 728. So for example, there are 001 to 728 students. So this is the number. So we can just um, give this number to each student from 001 to 728. So in a class, there are total 728 students. We want to randomly choose 15 students. So does it also depend on the population size? If the class was 20 people, for example, much better. Some, yeah, it is also depends on the population size and the sample size. Yeah. Okay, so there are total 728 students, and each student has numbers from 001 to 728. So now we can just randomly select a number. So from line number 3, and this is column number. So this first number is 069. So that's mean 069, the student who has this number is selected. And this number is random number. So now the next number is 988. So we are not going to select this one because we do not have 988. So go to the next number, 386. So the next number is 386. So that's mean 386 is selected. The student who has this number is selected. Then 539 is also between 001 and 728. So we also select this student. Then 303, then 097, then 628, then 458, 759. But 881, we do not have 881. So this is cross. So we are not selecting this one. Then 009, yes, we have 009, 036, then 981. So we do not have this one because we have only 001 to 728. Then the next number will be 652, then 694, then 024, then 178, and then we'll go this way, 849. So we do not have this number. Then 578, and you have to also be careful about repetition of the number. So if you already selected one number, so you're not going to select that number again. No, 759. Yeah, so yeah, you're right. So it will not work because we do not have 759, right? Because our numbers are 001 to 728. So 759 will not work. Yes, you are right. Thank you. Okay, so in that way, we'll just those 15 numbers and the students corresponding to those numbers. Okay, so nowadays people actually use statistical software or graphing calculators. You can also use graphing calculator to generate some random numbers instead of using random number tables. Okay, so there is another example of random number table. So a class has 50 students. Use the second row of digits in the random number. So this is the second row. So we'll use this row to select how many students. We want to select 3 students, right? Yeah, 3 students. And the numbers are from 1 to 50. So what are the numbers of the 3 students selected? So now you have to determine the numbers um, selected for the 3 students. We'll start from the second row. It said that start from the second row. So let's see. So the first number is 89. Since 89 is not from 0 to 0, 1 to 50, so we are not going to select this one. Then next number is 09. Yeah, we are going to select this one because 09 is from 01 to 50. Then next number is, so we selected 09. Next number is 09. Since we already selected this one, so we are not going to select this number. Then next number is 00. So 00 is not from 01 to 50. So we are not going to select that one as well. Then 14. Yes, 14 is from 01 to 50. So we are going to select 40. Then next number is 66. So we are not going to select 66, then 56, then 71, 39. Yeah, 39 is between 01 to 50. So the next number will be 39. Yeah. This is how you will select the random number from the random number table. Yeah, so 9, 14, 39. So why can't we do 15? The next number is 15, but we only want to select 3 students, right? So we already have 3 numbers. Yeah, very good question. So the next number is, yes, next number is 15, which is from 01 to 50. But we already have our 3 numbers, right? So we do not need to select 15. Yeah, okay. Actually, this is all about the first chapter. The first chapter, we just only covered section 1.1 and section 1.2. We are not going to cover the other sections. So do you have any question? No, it will go by order. Yeah. Yeah, it is not the preference. It will go by order. Yeah. Okay. So any other question? I think I missed some question. I'll try to answer all the questions because someone was asking. Okay, instead of typing, if you use the microphone, that would be better because I might miss your questions. Okay. Okay, so let me stop.